So we have this equation. We immediately, well, once we diagnose that this is a higher degree equation, by higher we mean higher than degree 1, that means we have to reduce one side to 0, factor and apply the zero product rule. There's nothing else under the sun. Also, you might see a huge GCF on both sides if you're tempted to divide resist. So what we're going to do is reduce one side to 0 without creating negative leading coefficients. That means that this should stay where it is. So we're going to subtract 3x to the 6th power. So now let's factor. There is going to be a sizable GCF, right? So between the numbers, the 3, between x to the 7 and x to the 6, they both have at least x to the 6. And then 3 to 6, that's a 2. X to the 6 to x to the 7 is x. And 3 to the x to the 6 is there. We already have it. Sometimes that's confusing, but we can't just lose a piece because then the multiplication backwards doesn't work. When we factored out everything, what's left is a 1. So then the multiplication backwards works. All right. We have a product of 8 factors. 6 of them are x times x times x. And then there is a 3, and there is a 2x minus 1. And this product is 0. Well, how can that be? 3 will never be 0. X to the 6, or x, is 0 when x is 0. So that's a solution. That's a solution you would lose if you divide it by what we should just factor out. And then 2x minus 1 equals 0 is the other linear equation, which we solve for x. So we have two solutions, 0 and 1/2. If we go back to the original equation, 0 is very clearly going to work. And if we use x equals 1/2, then we have 6 times 1/2 to the 7th power on the left-hand side. And on the right-hand side, we have 3 times 1/2 to the 6th power. Well, I'm going to be a little bit lazy here, but what if we just take 1 out of the 7 here? 1/2 to the 7th power is 1/2 times 1/2 to the 6th power. And then this is 3, and this is 1/2 to the 6th power. So actually both 0 and 1/2 work. So those are both solutions. Thank you for watching.